is Academic Decathlon, worksheet number 8. In these problems, they say find the inverse function. And the inverse function, so when we want to find inverses, so here's the function, something like f of x equals 3x minus 2. And so the inverse of that would be reversing the two variables. Let's make this a little bit smaller. Let's group it. Not ungroup. Hello. Let's group it. Would be reversing the two variables. So where you see f of x, you're going to have x. And where you see f of x, you're going to, and technically a lot of people like to do this. And then they will write 3y minus 2. So you're just reversing the x and the y and then solving for y. So you're going to add 2. So you get x plus 2 equals 3y. You're going to divide by 3. And you get x plus 2 over 3 equals y. And that would be the inverse. And inverse function. It's not a function because we made it y, but so you'd have f of x and then this little prime, that's called prime, equals x plus 2 over 3. That's how you would find the inverse function. And that notation is saying that you're taking the inverse of it. So we notice it, or f to the negative 1, which also means inverse. So what I'm going to do is I'm going to substitute y in for f of x just for purposes of writing it and solving it and moving all these variable things. That should be a y. So we're going to subtract 8, and then I will flip it back at the end. So you have 8 minus x equals 2/3 y. Let's multiply by the reciprocal. When we multiply by the reciprocal, we have to do everything times 3/2. So 3/2 x minus 12 equals y. Because negative 8 times 3/2, the 2 in the denominator is going to cancel with that. And 4 times 3 is 12. So now, if we want to write the inverse function, we would write f of negative 1 of x equals 3/2 x minus 12. So that would be the inverse function of that initial function. Woo, baby. Wow, they jump out at you. Okay. So we're going to write y equals the cube root of 2x minus 4. So if we flip everything, we're going to write x where there's a y, and we're going to write a y where there's an x. So 2y minus 4. So how are we going to get rid? We can't get in here until we get rid of that cube. What gets rid of a cube root is a cube. So we will cube each side. X to the third equals, now you have 2y minus 4. And now we can add 4. You get x to the third plus 4 equals 2y. Divide everything by 2. And well, you can have a number, assorted answers. Oh, come on. X to the third over 2 plus 2 equals y. You can, that's probably best. You can have 1/2 x cubed plus 2 equals y. Or you can have this as your answer. So I'm gonna write f of negative 1. F inverse of is going to be, which one am I going to use? I think x to the third over 2 plus 2. It's a horrible x to the third. Yeah, I like that one. All right, y equals 4x squared minus 1. So let's flip it and write x equals 4y squared minus 1. Let's add 1. You have x plus 1 equals 4y squared. Let's divide by 4. You have x plus 1 over 4 equals y squared. We have to isolate for y, so what's going to get rid of a square is the square root. So we have the square root of x plus 1 over the square root of 4 equals y. And I separated those because that'll equal that equals y, and then we can write it as a function. So f to the negative 1x equals the square root of x plus 1 all over 2. Y equals negative 3x. The function inverse would be x equals negative 3y. Divide by negative 3. And we get x over negative 3 equals y. So f of negative 1, x equals negative, x over negative 3. Changes. So given our function, f of x, and our transformed function, g of x, describe the changes made to the graph. Okay, so we're not doing inverses. We're applying a shift, a stretch, a shrink to it. So if we look at this graph and we plug in 0, we get 5. So 1, 2, 3, 4, 5. We can start plugging in points. If we plug in 1, we get 4. So 1, 4, 2, 3, 4, no, 3. 1, 0, 1, 1, 4, 3, 2, 1, and then here, and then 1, 2, 3, 4, 5. So if we plug in 5, we get 0. And guess what we get if we go to 6? 6 brings us back up into that shape. So if we graph those solutions, we see that that absolute value graph has a shift of 5. So this is shifting it along the x-axis, positive 5. So shift 5 to the right, but that's just that's our parent function. That's the original. And then we're going to transform it. So what happens to this one? Whew. Wow, that's weird. All right. So usually the parent function is f of x equals the absolute value of x. Usually they give it to you with the parent and nothing's happening to it, but that's okay. So if we do this, we know this is going to shift 1 to the left. So my vertex, this is considered my vertex. So my vertex gets shifted 1 to the left and down 3. So that is where my vertex is going to go. That's my new vertex. And look, if we plug in negative 1, negative 3, what would we get for my, or if we plug in, negative 1 for my x value, what would we expect to get? We would expect. So if we plug in negative 1, that gives me 0 times 2 is 0 minus 3 is negative 3. And it worked. So when we plugged in negative 1, we got negative 3. Now everything's going to move off of it. Now, you also have this coefficient which acts like a slope. So my first point is going to be rise over run. It's going to be up to right 1, and it should be right here. Let's test it. If I plug in 0, do I get negative 1? Because that would be the point. So if I plug in 0, I get negative 1, and I did. So my left side of it's going to go to the left, and it'll be here. So that'll be my next one. So this graph is going to be much more narrow. So it's going to go up to right 1, we get that point. From this point, we're going to go up to left 1. So we see that it's much more narrow. So there's a horizontal shrink of of 2, maybe 1/2. Is it a horizontal shrink of 1/2? So let's look and see. Horizontal shrink of 1/2, I'm going to say. And then where does it go from the vertex? 1, 2, 3, 4, 5, 6 to the left and down 3. Left 6, down 3 is my shifting. Shift horizontally left, horizontal left 6 or horizontal -6 and down 3. So that'll be interesting to see if that's what they want, the changes. That was pretty sophisticated as a first problem. So I'm going to have to look at the answer key. All right, so here is a parabola. So let's write this in black. And parabolas and absolute values and lots of things will end. Sine curves, all will have it. So when I plug in 0, I get 0. When I plug in 1, I get 2. When I plug in 2, I get 8. 3, 4, 5, 6, 7, 8. And when I plug in -1, I get 2, because -1 squared is 1 times 2. When I plug in -2, I get 8, and that is my parabola. Here's my vertex. You have an axis of symmetry. Let's do it in blue. So you have an axis of symmetry that is along the vertex. This is the vertex. And you again have somewhat of a slope that definitely affects your outputs. So when we have this new graph, when I plug in 0, I get 6. 1, 2, 3, 4, 5, 6. So this is a shift up 6, and this is going to affect, and that's actually going to stretch it along the horizontal, because it's going to go up to right 3, so it's stretching wide-wise. So that's my first point. If I plug in another number, I'm going to plug in something like 3. And why 3? Because of that denominator. My x's are going to be multiples of my denominator, so they can cancel. So that's 9. So that's 12. So we're going to be up here, 3, 12. And then if we plug in -3, we get 12. -3, 12. And you notice that it's much more wider on the bottom because it's moving outward. So what is the transformation from this vertex? So that transformation is going to be up 6, shift up 6. It's not going to move left or right. And then it's going to be a, I don't know if it's called a vertical or horizontal stretch. We'll say vertical stretch of 2/3. We'll have to look into this and do a better job. I did not prep this, so I'm sort of just trying to remember Algebra 2. This is primarily Algebra 2. Now, when we get inside, so there's a difference. This is your H value, and this is your K value, moving your vertex, because this is in vertex form. So my vertex is going to be 1, 2, 3, and then up 2. So my vertex is here because the function, it is y equals a times the quantity x minus h plus k. And we see that what we see is the opposite of my h value. So my vertex is going to be -3, 2, which is what we did there. And then there's no stretch or shrinkage. So we're going to get everything else will run like a parent, like y equals x squared. So it'll be here and here, and then it'll be 2 up, and it'll be 1 here. So you'll get this, you'll get your regular parabola shape. This tells me it's flipped across the x-axis. And then my vertex is moved. So my vertex is -5, -6. So it's going to 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. It's like this, and then it's going to move. It's going to go upside down. So we're going to move 1 over here, 1 over here, 4 down, 4 down. So it looks like this. Same shape, just shifted and flipped. So flipped across the x-axis, and we are going to shift it from the original. We went from -3 to -5, so 2 to the left, and we went from +2 to -6 and down 8. So it'll be interesting to see if they want it from this to this, or whether they just want to know where is its position from the origin. So I would assume that it's these two pieces. Again, it'll be interesting. All right, warm up. Warm up's easy. We're going to solve for r, so we'll isolate it. A equals pi r squared. Let's get rid of that pi first. We want to isolate our variable. A over pi equals r squared. What gets rid of a square is a square root. And we get plus or minus, oop, I didn't want it in red. I'm pretty sure we need a plus or minus a square root of a over pi equals r. I'm going to guess that we do plus or minus. Let's think about it. Yeah, because we're squaring r, so we can get a negative. However, radiuses will never be negative, so I think we're going to go back to just that. That'll be a fun one to check. Solve for m. That's easy. It's being multiplied by that, so we will multiply by the reciprocal of x minus x sub 1. X minus x sub 1, so y minus y sub 1 over x minus x sub 1 we don't need. And hey, what is that? That looks like the slope formula when given 2 points. Yep, and this is point slope form. Solve for b. These are relatively easy. We've done harder ones in class, so these are kind of simple. We can do this in one fell swoop. We can divide by h and multiply by 2. So 2h, if we multiply it by, we get 2a over h equals b. That's nice and easy. That's layup. All right, I'm going to check if there's mistakes. You will see it in the detailed answer key, probably not on the video. So I reserve the right of making mistakes. We'll see.